Hello students, let's be discuss about the rest of the property of sulfur dioxide. In the previous video we have discussed about their acidic character, their reducing property, addition reaction, so on. Let's at first we discuss about the shapes of sulfur dioxides. Shapes of sulfur dioxide, it is the angular shape in which sulfur attached with oxygen with double bond and one lone pair present here. This is the sigma bond, this is sigma bond, this is p pi and d pi bond. It is the p pi and p pi bond. So you can draw the resonating structure also because it shows resonance in which here p pi, here is p pi d pi, one lone pair is here. So in this way we can draw the structure of sulfur dioxide, which is the angular in shape, and it is the +4 oxidation state. So student, it sulfur at +4 oxidation state behave as a reducing agent as well as oxidizing agent. In the previous video we have discussed the reducing property in which we see the pink color of potassium permanganate changes into colorless and potassium dichromate changes into colorless. Let's discuss about the oxidizing property of sulfur dioxide also. Oxidizing property, we see here how sulfur changes into sulfur dioxide changes to hydrogen sulfide into sulfur. So it will form H2O and sulfur. Similarly, carbon monoxide changes into carbon dioxide and so student, one another property is also a bleaching property of sulfur dioxide. So let's discuss the bleaching property of sulfur dioxide. As we discuss sulfur dioxide in presence of moisture, it gets converted to H2SO4 and gives nascent hydrogen. Any coloring matter when come into this contact of nascent hydrogen becomes colorless. So in this way sulfur dioxide also behave as a bleaching action. Now we discuss the oxo acids of sulfur. Our next topic is oxo acids of sulfur. Number of oxo acids are shown by the sulfur, like sulfurous acid. The formula of sulfurous acid, as we know, H2SO3. And what will be the structure of sulfurous acid, students? Try to draw the structure of sulfurous acid. So sulfur, one lone pair is present here, one OH bond, double bond, oxygen and one OH bond. This is the sulfurous acid. The structure is important for oxo acid because it will be possibility to come in the examination also. Next is the sulfuric acid. As we know, the formula of sulfuric acid is H2SO4 and their structure will be sulfur, double bond oxygen, OH and OH. Next one is pyrosulfuric acid. Pyrosulfuric acid. and the formula will be H2S2O7. And the structure of this pyrosulfuric acid is formed by the combination of two sulfuric acid, double bond oxygen, so, and here is OH, and one oxygen is connected to two sulfur atoms. Here is also double bond, and here is OH. This is the formula of pyrosulfuric acid, in which the molecular formula H2S2 and O7. Next one is the peroxo disulfuric acid. Peroxo disulfuric acid. Students, here the common name is also oleum. This compound is also known as a oleum. Next one is peroxo sulfuric acid. Peroxo sulfuric acid, in which obviously the name is given peroxo, means there will be peroxo, presence of peroxo compound also. So like this, double bond O, OH, O, single bond O, this is the peroxo, and sulfur, double bond O and OH. So this is the formula or structure of pyrosulfuric acid, and then molecular formula H2S2O8. So number of oxo acids shown by the sulfur, but we will study about few ones, only 4 or 5. So students, let's we discuss about the sulfuric acid, their properties of sulfuric acid. In this year, the preparation method will be deleted, may be deleted, or it has to be deleted. So we will discuss only the property of H2SO4, their physical property or chemical property. So at first we will discuss properties of sulfuric acid. Properties. It is the highly viscous in nature. At first write down the highly viscous, the high viscosity and the high viscosity and high boiling point is due to the intermolecular hydrogen bond in the molecule of acid. So see here how the formation of intermolecular bond, hydrogen bond takes place. This is the OH and the double bond O. One molecule is here, and again we draw the one molecules of sulfuric acid like this. So student, there is the force of attraction exists between this oxygen and this hydrogen, and this is known as H bonding. So due to presence of H bond in sulfuric acid molecules, it is by nature is highly viscous, and their boiling point is also high. This makes the molecules viscous and boiling point high. Let's we discuss about the character, means chemical property. Chemical property, at first we discuss about the acidic nature. Chemical properties. At first we'll discuss about the acidic nature. Acidic nature. So student, H2SO4 is a di-basic in nature. It is di-basic in nature and ionizes into two states and ionizes into two states in aqueous solution. Let's see at first H2SO4 in aqueous form dissolve in water. It will give hydronium ion aqueous as well as HSO4 minus and also in the aqueous state. Here the AC dissociation constant or first AC dissociation constant is greater than 10. It is found that experimentally. Now see the second step, when the bisulfate or hydrogen sulfate ion in the aqueous form dissolve in water, it gives hydronium ion, means one hydrogen again it gives, and sulfate ions in a aqueous medium. And here we will form the AC dissociation constant. Second AC dissociation constant is equal to 1 into 2 into 10 to the power minus 2. So one question is given in your NCERT book. So what is the question? The AC dissociation, first AC dissociation constant of H2SO4 is greater than 10, whereas their second AC dissociation constant is less than 10 or equal to this 1.2 or 10 to the power minus 2. Why this will happen and what is the reason behind it? So let's we discuss, student. Ka2 value is less for the AC because negatively charged anion has lesser tendency to lose a proton as compared to the neutral acid. So in this way it forms in two salts, series of two salts, bisulfate. This is the bisulfate and this is the sulfate. So in this way we can clearly explain about their nature. The first AC dissociation constant is greater than 10, whereas second dissociation constant AC is found to be 1.2 into 10 to the power minus 2. So simply we can explain about these questions in the second step. This is the first step, student, and this is the second step. In the second step, bisulfate molecules is ion in the ionic form. So in the ionic form it is very difficult to lose protons, whereas H2SO4 is in the neutral form. So it can easily lose protons, whereas it cannot be easily lose protons. So that the first AC dissociation constant of this H2SO4 is greater than 10. That is the main reason for the difference in AC dissociation constant Ka1 and Ka2. This question is also given in your NCERT book. So pay lot of attention on this type of questions. Next we discuss about the properties of acidic nature. As we see here, after ionization it forms two series of salts, that is bisulfate and sulfate salts. Bisulfate HSO4 minus and SO4 minus 2. Two series of salts. So whenever we treated the H2SO4 with any strong base, it will form at first sodium hydrogen sulfate like this, and in the second step this sodium hydrogen sulfate again treated with H2SO4, so it will form, or we can write in this form also simply, or H2SO4 again react with sodium hydroxide, so it will form sodium sulfate and water. So what is the reason for formation of two types of salts? Whenever any strong base treated with H2SO4, because it is a di-basic in nature, so in the neutral form it can quickly release their protons, but in the ionization form as bisulfate do not easily lose the protons. That is the reason for the difference in Ka value, means acid dissociation constant value of H2SO4, means first acid dissociation constant and second acid dissociation constant. There will be found a difference between them. Let's we discuss about their other chemical properties. Another chemical properties, like it behave as a dehydrating agent. It behave as a dehydrating agent. Dehydrating agent. So whenever conc sulfuric acid, because it has strong affinity, strong affinity for water. So students, this is the reason for sulfuric acid behave as a dehydrating agent. So it is a powerful dehydrating agent. Powerful dehydrating agent. Suppose we take C12H22O11, and this is the formula of sugar, and conc H2SO4 treated with this sugar. So all the water molecules remove first in here 11H2O, and now we have black carbon left after this reaction. So this reaction show that the sulfuric acid is dehydrating in nature. In fact, it is a strong dehydrating property. Next property, action with salt. Number 3, action with salt. Action with salts. So it is, as we study about the property, it is high boiling point and less volatile in nature. It has high boiling point and less volatile in nature. Less volatile in nature. It liberates more volatile acid from the salts. It liberates more volatile acids from their salts. For example, with dilute acids. Dilute is decomposed like carbonate, sulfate, bicarbonate, so on. So when sodium carbonate treated with H2SO4, it will form sodium sulfate and carbonic acid. This carbonic acid decomposed into H2O and CO2. So this is with sodium carbonate. Again with sodium sulfite, when treated with H2SO4, it will form sodium sulfate and sulfurous acid, H2SO3, sulfurous acid. It is the carbonic acid, it is the sulfurous acid. With conc acid, this is dilute in the dilute with conc Conch acid decompose mainly fluorides, chlorides and nitrites. This type of salts is decomposed whenever we take, suppose we have calcium fluoride, when treated with conch H2SO4, it will form calcium sulfate and hydrogen fluoride. So in this way, suppose we have NaCl and we have H2SO4 and it is a concentrated, it will form sodium bisulfite NaHSO4, sodium bisulfate, not sulfide, and hydrogen chloride HCl we will get. So students, in this way we can explain the properties of sulfuric acid whenever the sulfuric acid treated with this type of salts corresponding volatile acids liberated. This is called carbonic acid. This is called carbonic acid and this is called the sulfurous acid. In this way we have completed our properties of sulfuric acid and their characteristic and the physical or chemical property. Why sulfuric acid is viscous or high boiling point? Simply we can explain on the basis of hydrogen bond. Let's we discuss about our next group, that is called the halogen family. So students, any text question or any exercise questions related to this topic, try to solve and try to write down the number of times in your notebook copy. So what happens when conch sulfuric acid is added to the calcium fluoride? This is the NCERT question. Simply you can write the formation of calcium sulfate and hydrogen fluoride. What happens? Sulfur dioxide dissolve in water. So when sulfur dioxide dissolve in water, it will form sulfuric acid. And also the uses of sulfuric acid and the structure of sulfuric acid and sulfate ion. So draw the structure of sulfate ion and bisulfate ion. Draw the structure of this and this also in your notebook copy and show me on WhatsApp number. Okay, let's we discuss about the group 17 and another question related to the topic of H2SO4, your NCERT book. We will discuss on the end of the week, that is Saturday. We will discuss about the questions of group 16 NCERT in text or exercise. One question is I also discuss here is why Ka2 is why Ka2 is less than Ka1 for H2SO4. So it is also an important question. I already discussed this question in this video, so pay attention on it. So students, in the next video we will discuss about the group 17 and their characteristic.